All right, we are going to fill out pages 8 and 9 today in our interactive notebook. Page 8 is just all definitions that you will need to be familiar with. Starting up at the top, just how do you name an angle? And it talks about the 3 different ways to name an angle. So you can name it by the vertex, call it angle A. You can also use a point on each ray, and you can call it angle CAB or angle BAC. And then you can also use the number associated with the angle and call it angle 1. You also have the different types of angles: acute, right, obtuse, and straight. You need to know the difference between complementary and supplementary. So complementary angles add up to 90 degrees. Supplementary angles add up to 180 degrees. Adjacent angles, you need to know adjacent angles share a common side. They'll also have a common vertex, but they're not going to have any common interior points. So angle 5 and 6 in this diagram is an example of adjacent angles. And then congruent, make sure you are familiar with the congruent symbol and understand if 2 angles are congruent, then they have the same angle measure. So again, you're going to be applying all of these definitions in section 1.5. So moving over to page 9, you want to make sure that you are folding your paper correctly. So you still want to make sure that you see the title of this section, which is measuring and constructing angles. On the front, you're going to see the angle addition postulate, which is very similar to the segment addition postulate, where you have that part-whole idea. So this gives you that angle RSP plus angle PST equals the whole angle RST. So that's that part-whole concept. And then down at the bottom, you have angle bisector. So bisector is going to be divided into 2 equal pieces. So here you have ray YW bisecting angle XYZ. So if it's bisecting an angle, it's cutting the angle into 2 equal pieces. So that means angle XYW is going to equal angle WYZ. So we're going to be using all of that information in order to complete the examples inside of your notes. So opening up the first example up at the top, we have a diagram. We have the given information. Angle IJA is represented by the expression 52 minus 4x. Angle AJK is given by the expression x squared. And we're also told that the whole angle IJK, this whole thing, is 64 degrees. So I like to just give myself that visual, substitute in that given information. And I'm told I have to find the measure of angle IJA and the measure of angle AJK. So in order to do that, I'm going to use my segment addition postulate, the part-whole. So that tells me that the measure of angle IJA plus the measure of angle AJK equals the measure of angle IJK. Part plus part equals the whole. And then I'm going to go ahead and substitute in the values that I'm given. So IJA, underneath that, I'm going to write 52 minus 4x. AJK, underneath, I'm going to write x squared. And then the measure of angle IJK is given to us as 64 degrees. So it looks like I have a quadratic equation, so I need to put this into standard form. So x squared minus 4x. And then if I subtract 64 from both sides, 52 minus 64 is negative 12. So that's minus 12 equals 0. And then from there, I could factor it, use the quadratic formula, put it into my calculator, whichever you prefer. I'm just going to factor it quickly because I know that -6 and -6 and +2 multiply and give me -12 and add to give me -4. So -6 and +2, so that's x minus 6, x plus 2. Set each one of these equal to 0 and solve for x. So x is 6 and -2. So now I have to plug that into these angles and get the measure of each angle and make sure they add up to 64 degrees. So I'll start with 6. If x equals 6, then the measure of angle IJA is 52 minus 4 times 6, because I'm just substituting 6 in for x. So 52 minus 4 times 6. 4 times 6 is 24, and 52 minus 24 is 28. So the measure of angle IJA is 28 degrees. And then if x is 6, the measure of angle AJK is 6 squared. And 6 squared is 36. So just making sure that if IJA is 28 degrees and AJK is 36 degrees, I want to make sure that using the angle addition postulate, it adds up to 64. So 28 degrees plus 36 degrees, does that equal 64 degrees? Yes. So you're just kind of checking to make sure everything matches. And then you're going to do the same thing for -2. So if x was -2, then the measure of angle IJA is 52 minus 4 times -2. 4 times -2 is -8, and 52 minus -8 is the same as 52 plus 8, which is 60 degrees. The measure of angle AJK would be -2 squared, which is -2 times -2, which is 4. And then again, if IJA is 60 degrees and AJK is 4 degrees, they should add up to 64 degrees. So 60 degrees plus 4 degrees, yes. 60 plus 4 is 64. So everything should match up, which means this particular example has 2 possible solutions. All right, down at the bottom, we're going to use the definition of angle bisector. So we're given that ray PN is bisecting angle MPR. So that means angle MPN is equal to angle NPR. So the measure of angle MPR, so this whole angle is 120 degrees. So I'm not even going to look any further. I'm just going to use the fact that the whole angle is 120. PN is bisecting the angle, so that means each piece has to be 60 degrees. So let me zoom in and just show you. There it is. So just start filling in information that you know. Okay, we're also given that angle MPN is the expression 1/3 y plus 8x. So I'm going to put that in there as well. So not only is it 60 degrees, it's also represented by the expression 1/3 y plus 8x. And then the other information is that the measure of angle NPR is 12y minus 12x. So I'm going to put that in here as well. NPR is given by the expression 12y minus 12x. So now I know that 1/3 y plus 8x has to equal 60, and 12y minus 12x has to also equal 60. So I'm going to write those two things down. 1/3 y plus 8x equals 60, and 12y minus 12x has to equal 60. Those are the two things I know from all of this given information. So now I have a system of equations. So you can solve this system of equations by using the graphing method, substitution method, elimination method. It doesn't matter. I've used both substitution and elimination to solve this problem, and you get the same answer. So whatever your personal preference is, for this particular example, I'm just going to use elimination to model it for you, but feel free to use substitution as well. So I'm looking at my x coefficients, which are 8 and negative 12, and either those both can go into 24 evenly. So I know 8 can go into 24 3 times, and 12 can go into 24 2 times. So when I multiply 8 by 3, I get positive 24x, and negative 12 times 2 is negative 24x, so I can get those x's to eliminate. So multiplying everything by 3, so 3 times 1/3 y is just y, 3 times 8x is 24x, and 3 times 60 is 180. Then I'm going to multiply the bottom equation by 2. 2 times 12y is 24y. 2 times negative 12x is negative 24x, and 2 times 60 is 120. So now when I add these two equations, the x's are going to get eliminated. And I could add the y's. 1y plus 24y is 25y equals 180 plus 120 is 300. So if 25y equals 300, divide both sides by 25, so y is 12. And then I could use either one of these to get x. So if you use 1/3 y plus 8x equals 60, so if you just pick the top equation and substitute 12 in for y, you'll have 1/3 times 12 plus 8x equals 60. 1/3 of 12 is 4. Subtract 4 on both sides. So 8x equals 56, and 56 divided by 8 is 7. So you'll get x is 7, y is 12. And you can check that by using the equation that you didn't use in your substitution. So I used the top equation to solve for x, so you could use the bottom equation to check. So if you do 12y minus 12x equals 60, and you substitute in 12 for y and 7 for x, you get 144 minus 84, which is 60. So that works out. And you could also copy down the other equation and just double check your arithmetic. Substitute in 12 for y, 7 for x. So 1/3 of 12 is 4. 8 times 7 is 56. Good. And 4 plus 56 is 60. So that just verifies your answer of x equals 7, y equals 12, because that will give you two congruent angles of 60 degrees, and then 60 plus 60 still gives you the whole angle of 120.